day everyone. I am Vic Alfred E. Mahasol and today I will discuss about constitutional isomers. In this presentation, we will learn what constitutional isomers are, why they occur, their example, how to name them using a UPAC rules and their physical and chemical properties. So let's begin. So let's proceed. So what are constitutional isomers? Constitutional isomers are compounds that have the same molecular formula but different structural arrangement of atoms. Meaning, pareha sila og molecular formula pero lahi ang pag-connect sa ilang carbon atoms. That's why they are also called structural isomers. For example, ang CH4 o H10 can exist as butene and isobutene. Same formula na sila pero lahi-lahi ang structure. So let's proceed. Molecular formula versus structural formula. This slide shows the difference between molecular formula and structural formula. Ang molecular formula only tell us the number of atoms in a compound, for example, CH4, H10. On the other hand, the structural formula show how the atoms are connected. Mao ni ang importante sa constitutional isomer because bisan parehas ang molecular formula lahi ang ilang arrangement. So, why constitutional isomer occur? Why do constitutional isomer occur? Carbon can form for covalent bonds. So, flexible kaayo siya sa pag-connect sa uban carbon atoms because of this different arrangement. Are possible this different arrangement produce different compounds with different physical and chemical properties, even if they have the same molecular formula. So, let's proceed. Slide number 6. Example, octene. Another example is octene. With the molecular formula CH8, H18. Octene has 18 constitutional isomers. Sa slide, duha lang ang example which are N-octene and 2-methyl-heptene. Although same sila og molecular formula, lahi ang carbon skeleton or arrangement sa carbon atoms. So, let's proceed. Slide number 8. Longest carbon chain steps. When naming constitutional isomers, the first step is to find the longest continuous carbon chain. Next, number the chains from the nearest branch. Then identify and name the branches. In this example, the longest chain is butene. The branch is methyl. So the correct IUPAC name is 2-methyl-butene. Now let's proceed slide number 1. IUPAC naming rules. Now let's talk about the basic IUPAC naming rules. First, find the longest carbon chain. Second, number the chain correctly to give the substituent the lowest possible number. Third, identify the substituent or branches, then arrange them alphabetically. If they are two or more identical branches, we use prefix like di, tri, and tetra. In this example, the correct IUPAC name is 2-methyl-butene. So let's proceed. Slide number 7. 5 isomer of hexene. For hexene, the molecular formula is CH6H14. It has 5 constitutional isomers. These are hexene, 2-methyl-pentene, 3-methyl-pentene, 2,2-dimethyl-butene. and 2,3-dimethyl-butene. All of these have the same formula, but each one has a different carbon arrangement. Now let's proceed. Slide number 10. Physical and chemical properties. Lastly, let's discuss the physical and chemical properties. Most constitutional isomers of alkenes are colorless, nonpolar, insoluble in water, and flammable. Their, their boiling point generally increases and the carbon chain becomes longer chemically. They undergo combustion, halogenation reaction, and are stable under normal conditions. Now, let's proceed to slide number 11. Importance in agriculture and organic chemistry. Now, let's talk about the importance of constitutional isomers in agriculture and organic chemistry. In agriculture, these compounds are important because they are used in the production of pesticides that help protect crops from pests. They are also used as fuel for farm machinery, mach- uh, uh, machinery like tractors. Some organic compounds are used as raw materials in making fertilizers, and they are also used in making plastic containers and irrigation pipes used on farms. In organic chemistry, constitutional isomers are very important because they help us understand the structure of hydrocarbons. They also help scientists study how the arrangements of atoms affects the properties of compounds. This knowledge is useful in pharmaceutical and industrial chemistry for making medicines and other useful products. And now, in summary, to summarize my presentation, constitutional isomers have the same molecular formula but different structural arrangement of atoms because carbon can form for covalent bonds. Many different isomers can exist. We also learned that IUPAC naming provides a standard way of naming these compounds correctly. Lastly, constitutional isomers are very important not only in chemistry but also in agriculture because they have many practical applications.